This lesson is going to talk about composition of functions. Composite functions are a function inside another function. So composite functions are a function inside another function. Well, what do I mean by that? An example is h of x equals the square root of x plus 1. So this x plus 1, this expression, this is a function underneath the radical sign. So we would have the function f, which would be the square root of x, and we would have the function g of x, which would be that x plus 1. The x plus 1 is replacing, or it's inside, underneath the radical, it's replacing that x. Another example of a composite function is m of x equals, let's say, 2x plus 1 squared. So I wrote in blue the inside function 2x plus 1. The outside function, f of x, is x squared. G of x, the inside function, is that 2x plus 1. The 2x plus 1 is what's being squared. So the notation for writing composition of functions can be f of g of x. This is read f of g of x. You could also write this as f of g. This little dot, or circle I should say, is not multiplication. Now here I gave you some composite functions. Now I'm going to give you two separate functions and we're going to find their composition. So let's say f of x is x squared plus 2. G of x is 3x. And I'd like to find f of g of x, meaning the g of x, the function on the is on the inside of f. Remember, this can also be written as f of g. So what we're going to do here is we're going to place the 3x where we see the x in our function f of x. So we will have 3x squared plus 2, which will simplify to 9x squared plus 2. So g of x is inside the f of x. Now let's do it the other way. Let's say we want to have g of f of x, meaning the f of x is going to be inside the g of x. So if our two functions, remember we had our two functions, f of x is x squared plus 2, g of x is 3x, the x plus 2 is going to get substituted for the x in the g of x. So f of g of f will be 3 times x squared plus 2. Distributing the 3, you'll have 3x squared plus 6. And what I want you to notice here is the two functions are not necessarily the same. The f of g, remember this is f of g, is not always going to be the same as g of f.